this compartment. The negative ions do, to keep this thing neutral. Over here, the positive ions are going to come in here. As the electrons are coming in, it's also bringing in positive ions to keep that neutral as well. We don't have to train matter to do this. It just knows to do that. Charge can't build up. So down here, it describes the salt bridge. Contains an electrolyte solution whose particles can flow into either container to keep the overall charge zero. Yes, sir?
So if you touch the graphite, what do you think on the shaft? If you touched any part of it, could it shaft?
If there were a high enough voltage, yeah. Less than 1 volt is not, you can't even feel it, you don't even know what's happening. Even 3 or 4 volts with these concentrations, you probably wouldn't even know it. But yeah, if they were high enough voltage, that you could feel it.
Is that like when you go, like some physical therapists will use the electrotherapy?
Yes.
Like it's just kind of fuzzy?
Yep. Yep. I've had that treatment too.
Still feels good.
When they turn up high enough, it starts to hurt.
Yeah, that's what I meant. Just kind of like,
Yeah, yeah. We give the left compartment a name. Where the oxidation is occurring, what do we call this part?
The anode.
This is the anode, right.
It's kind of like oxygen.
And this is the cathode. The anode is where oxidation occurs. The reduction occurs in the cathode. Do you have a memory trick for remembering which is which?
Bells and constants go together.
What's that?
Bells, oxidation, anode, constant.
Yes, that's the way I remember it. Anode and oxidation both start with a vowel, so they belong together. Cathode and reduction both start with a consonant, they go together. Yeah, and I always put them in alphabetical order too, with the anode on the left and the cathode on the right. You don't have to do that. You can certainly put the anode there and the cathode there, but when you're asked to draw, to sketch out a cell, which you will be, you'll see in the homework exercises, it's going to say label the anode and label the cathode, so, and label the direction of electron flow. The electrons always go from the anode to the cathode. Now, if you put the anode on the right, just make sure that you put the electrons going from right to left. That's fine. You'll find, though, I just by convention, meaning that I always try to do the same thing, I'll put the anode on the left. So if you want to mess with me when you do your quiz, put it on the right, so I have to turn my thinking around.
Fun.
So you have to mark it wrong.
Oh, I'll look to find what I can mark wrong. Some people think like red cat, an ox, red cat. I don't know. I'm not into cats, I guess. Red cats especially.
He's orange. He's an orange taffy.
You like cats, Rob?
Yes, very.
How many do you have?
I don't have any.
Oh, you don't
I
have
plan
any.
to have around 20 when I grow up.
No, don't have 20. That's nasty.
I'll have 10.
I won't give you your
cat
hand or your library.
People will talk about you like within a mile radius of your house. Oh yeah, the cat will be nasty.
I'll have 5.
Cat litter everywhere.
Even 5's too.
5 is not that.
The only
Yeah.
pet I
They'll
have.
smell your house from the
You
side.
gotta do an
Fine,
oxidation.
please. Gosh.
I'd go with
Yeah.
1 just to be safe.
2?
Got
And I
it.
was like, how do you live? She
Yeah.
always
yeah,
has scratches.
Oh,
I'm
gosh.
like, come on.
Fine,
Yeah.
I'll have 2. Happy.
Yeah, that
Yes.
I'm good with that.
I'd say 1 just to be
I
safe.
only have
You have my
one
blessings, Robbie.
I have a lot.
All right, can we move
Oh,
on?
I want a tiger.
I want a lion.
Oh yeah, that would be great.
Just be like, hey.
What did I just do?
Tigers
Okay,
are
that went
cute.
ahead twice.
Except the E.
So I don't know how much you need to write of this. I mean, we can take a long time just writing all these words out. Just know that I was asked a question on the quiz. I think it was on your version of the quiz about what cell potential, what another name for cell potential, is also known as electromotive force.
Sound
The cell potential is related to how much does zinc want to oxidize and how much does hydrogen want to reduce. the more this wants to oxidize and the more that wants to reduce, the higher the voltage is going to be, the higher the electromotive force. So it has that not all things, not all reactions will produce the same voltage. It depends on how reactive your reactants are. That's what this is talking about now. Okay, it has to do, this thing in red here, the potential difference, is related to like the activity series of the metals. Zinc reacts very well, it oxidizes very easily, so it's going to give a pretty high voltage. Other things like silver don't have a very high voltage, for oxidation at least. Gold is terrible for oxidizing, it's just not reacting. Yes?
So are we gonna have to like calculate that?
Yeah, the calculation is super easy. I'll show you. There's a table of values. You can look up the oxidation potential of this, the reduction potential of this, and just add them together. That's all you have to do.
Okay. So the oxidation reduction, yeah, the potential is they give you like how much the voltage of the overall cell would be. But then how do they say that then increasing the molarity of the cathode?
That's for later. When we get into, so today we're going to just start with standard conditions, which is 1 molarity of everything.
Oh, is that
But when the concentrations aren't 1 molarity, then we'll talk about, okay, what if they're not 1 molarity and increasing or decreasing the concentration, how it affects. We're not quite there.
So the reduction potential tells you if both the solutions were at 1 molarity, then what?
That's right. That's right. Yeah, the table values are standard. Lena! I'm sorry, I should have called on you first because you're the lady here and Vinny couldn't go last.
No, it's
Ouch. I'm so sorry.
You're very gracious, Lena. Thank
I
you.
believe in equality.
Oh, equality, yes.
Okay. Darn it, all this talk of if gold.
What's up, Lena?
So like if gold is okay, seriously.
No, please, just ask your question.
If gold and silver are bad at like doing the thing, how
Yeah.
come they're such good conductors?
Oh, no, the conduction is not about how reactive something is. The conduction is just the ability for the electrons to flow through it. Oh, I'm losing you. So that is not related at all. Reactivity has to do with...
You're shaking everywhere.
Yeah, I'm sure. Oh my gosh.
Look at that.
Wow. Wait, I wasn't
You
gonna
enjoy
start.
yourself.
I thought we had a deal.
You made a mad face when I said there's a mad person.
I was not there. Wow.
Yeah, I don't think so.
I probably. Can you edit that out?
Anna's going to like that.
No.
All right. So anyway, the voltage is just a conversational kind of word. The official word is electromotive force or potential difference. But it's just easier to call voltage because then that's more descriptive, I think, than the other two terms. Voltage has to do with how much the electrons are being pushed through the wire. The push through the wire. That's not the same thing as current. Voltage and current are related to one another, and take physics and you'll find out what that relationship is, called Ohm's law. But current has to do with how many electrons are flowing through at one time. Voltage is how much they're being pushed. It's like the force pushing the electrons through. So I'll get out of the way.
Wait.
So yeah, volts are joules per coulomb, which has to do with how much energy it takes to push every coulomb through the circuit. Where current is measured in amperes, which are coulombs per second. It's like the rate of current flow. So they're not quite the same thing. They're related to each other, but they're not the same thing. Yes, sir.
So basically, taking an ampere, trying to electrolyze something with an ampere could take a different amount of force.
Yes.
Okay.
Yes, depending on what the resistance in the circuit is, yeah.
So you can't just like say, oh, I'm putting 1 ampere of current through this because then.
Depends on what the voltage is. Like if you want to electrolyze something or whatever. Yeah. Sorry you have to wait so long. Procky has to change pens every time she takes a breath.
No, I'm not.
Oh.
I'm only using orange.
I'm only teasing you. I know this is not true.
Oh wow, he's not teasing me.
No, because we have a deal, Robbie.
Which you broke. Which you broke. It's like 10 times today.
You look mad, so I just had to say something. You go back and watch.
But who's the other person that she chose?
I don't know. Who else did you vote for? You get 2 tickets, right?
Yeah, I voted both of them.
Oh, Sarabi.
Oh.
We're good forever. Have as many cans as you want.
I voted both tickets for us. And then I took my friend's tickets and voted.
Yeah. That's a great point. If I could mention that, I know how confusing that sounds. The thing that reduces is called the oxidizing agent. And then the thing that oxidizes is called the reducing agent. And at first you think, my gosh, that's so confusing. Why would they do that? But the more you're around electrochemistry and the more you realize the interrelationship between the thing oxidizing and the thing reducing and how one depends on the other, it does make more sense. So yes, the thing that oxidizes is the reducing agent. When the College Board decided they were going to change the curriculum for this course, they vowed they would leave off those terms, oxidizing agent and reducing agent. They're in the book, though, so we can't really get away from them. By the time that we're done with this chapter, you're not going to have much confusion about those terms, so don't. It's fine. Yeah?
Is the oxidizing agent, is it the container that's oxidizing?
No.
No.
It's the container that's reducing is the oxidizing agent.
Yeah, that's because like it's oxidizing the other thing.
Yes, it's allowing something else to oxidize. Yep. Yep.
That was just such a mess.
Uh-huh.
Zoomed off wall.
Okay, so we call this system an electrochemical cell. Specifically, this type of system is called a voltaic cell. Voltaic or galvanic cell. Or galvantic. Yeah. Those terms were in the book, I think, weren't they? Voltaic and galvanic cell?
Just galvanic.
Okay.
And it all started with a frog.
What?
Wait, it did.
Wait, what?
Okay.
They were dissecting a frog and then it's like, oh,
No, it didn't.
the frog's leg twitched or something, so then they found out.
Is that right?
I'm
Yeah,
pretty
that's
sure
how
that
they
was
found
another
it.
guy, Vinny.
That's Volta and Galvan.
Seriously?
I'm not
That
even
was
kidding.
another person, okay.
Mohammed?
What's the difference?
It's true.
No, they're the same thing. A galvanic cell and voltaic cell are the same thing. It's this kind of setup.
Oh.
Where you have your oxidation and reduction separated and connected by a wire.
Is that an E or like a
That's
sound?
It is a Greek letter epsilon.
Never.
It's epsilon. The book, epsilon, looks different from this one. You remember
Such a
seeing the one in the
fancy
book? Oh, yeah. Oh,
That was
that
like,
was
woo!
so nice. You get one of
Yeah,
these,
I know.
something like that.
No, that was like
They
loopy.
kind of curl.
Wait,
I
that's
don't know.
No, it was
Normally-
kind of like woo.
That's how I normally
Yeah,
write my E.
yeah,
So.
yeah.
Like,
That's how you normally write
Yeah.
these.
That's how I normally write
So
it.
yeah, I just went to the Greek fonts on in this program, and that's what I got for epsilon. But
That's how I normally write my E.
Wait, what? Let me see.
nice.
I think.
Wait,
Natural.
let me see.
No, it's a different one.
Wait,
Except
where's
for the
why
thingy in the
do
bottom.
you-
Because I don't know. That's my head.
You like it then?
So I want you to notice that the potential of the cell potential. So that's what that epsilon represents is potential. How reactive are these substances? So it would be the oxidation potential of the thing that's oxidizing, plus the reduction potential of the thing that's reducing. Now we can look those values up. There's a table in the book. I want to show you that when you're done writing this. I'm embarrassed of this. I have. Sorry about you guys being pushed all the way over there. I keep forgetting to move the desk back. It's kind of waggy. You have a bad angle. Like, James, can you even read that? Read it okay?
You just